Welcome back, folks, to the Next Best Speed Dating. Now we're looking at a game brought to us by Rye Elder Sage of Bread, The Joy of Programming. We're in the game. We're looking at its Steam page within the game, apparently. Start programming? Well, let's go ahead and play the game. Start game, play scenario. Let's start the game. Scroll the mouse wheel to change the font size in the code editor. Neat. Is there a code editor around here? I was gonna say, I saw Python there. Welcome. Pan the camera with WASD. And mouse to move to the edge of the screen. Okay. Or you can move it to the edge of the screen. This can be weird in windowed mode. Rotate it by holding right mouse button. I picked that up. Zoom using the scroll wheel. Goals. Click the delivery container. There it is. Alright, open the door. Okay, so it has a function there, or a method rather, to open the door. Open sesame. And then we want to click the conveyor belt. Alright. Set the speed to any number greater than 0. Oh, I have to move the slider. Is that good enough for you? Ah, there we go. I had to click that to actually activate the function. You like the concept of programming games, but playing them makes me feel like I could get the same effect and be more productive than actually programming. You know, that's why I'm hesitant to play a game like this, because it's just like, it feels like work. There's a for loop or something. Forwards. Deliver the box. How does one deliver the box? We did it. I clicked a bunch of buttons. I'm the coolest. My beat time was in the center. I was taking my time. Most levels, there's a hidden briefcase containing interesting information. Why is it interesting? Find out at 11. Print Hello World. Okay. The infamous Hello World program in Python. It prints Hello World on the screen. Yeah, that's it. Sorry. A predefined function, which is print, we can use. Print does exactly what the name implies. It prints stuff on the screen. These are called parentheses. We call and invoke a function within these. Inside is a literal string of hello world that needs to be printed. We need to surround it with quotation marks here, like hello world. If we're using a variable, of course, we could just put the variable in there. We can omit the marks. You will actually learn Python playing this. Here's a literal float, a floating point number. The same concept applies to other functions as well, though they might be different and have more parameters. Oh my goodness. Someday we might be even making our own functions, which would be weird. Alright. So that's cool. Now what? Guess I'll close this. Code. So here we have some Python code. Lethal is very familiar with Python. It was something I wrote primarily more than 5 years ago. Nowadays I write Ruby and JavaScript primarily, but this is not so alien to me. Alright, so we have a PyJob or Joy of Programming module that we're just importing everything from because we're maniacs. We connect to a SimM, okay, which is our simulation environment. We're printing hello world. We sleep for 1 second. Let's see, we have a conveyor belt, which we're finding by what looks like just an ID string. Then we set the speed of the conveyor belt to a positive to move it forwards and a negative to move it backwards. 0 means that it's not moving in any direction. Change the code to set the conveyor's target speed to greater than 1, or greater than 0. Oops. The hardest part for this, for me here, is going to be just using a non-Vim editor. I use VS Code nowadays, like everyone. So there you go. We set the speed to 1. We're the coolest. Drop the barrel on the floor. I was gonna say, just in case you can't see, there's the barrel. It looks like it's gonna fall on the floor by itself eventually. Why can't I scroll in my... No, stop. I want to go to my editor. I guess I can't edit while it's moving. Let's just let it fall off there. We did. We're the coolest. A float is actually when you put ice cream into your drink. We got 18 joy points. Python is an interpreted programming language. The interpreter converts Python commands into machine code at runtime. For each, we're learning about the loops. Let's say you want the sum of numbers between 1 and 99. Using a Gauss summation is not allowed. It is verboten. Fuck you. You shouldn't even know what that is. The above code is a bad idea. It's a lot of typing. It's prone to errors, and it's not exactly reusable. Well, if we use something like this, then we could easily add all the numbers. Whenever you need to execute something repeatedly, using a loop is one way to do it. So we have a for loop. It has a range that goes through 100 numbers, 0 to 99. It places that number in the I slot, in the I variable, as it were. So we're going to go through this loop 100 times, and every time we do it, we're going to go ahead and add 1, or the I, to S. Also in Python, we use blocks with indentation, which is a little different from a lot of programming languages. Some programming languages, like JavaScript, will use curly braces in place of something like this. And with things like Ruby, it's completely different. It's literally going to show us all of those, huh? Let's just go ahead and jump forward in that. There you go. Happy coding. Alright. Use speed up. Watch the introduction. Try the control buttons in the lower right corner. Okay. Time dilation. Oh, someone's just throwing boxes. Slow down or use pause. Okay. Reset the simulation. There, we did. Alright, perks. We have perks. What the fuck? We can unlock keywords with our science points. Okay, cool. So you want me to unlock a for loop. Got it. We don't even have if statements yet. Why is it on fire? Are those just tires? What are those? Those are just flaming tires. You got a nice tire fire going, and you need to burn some stuff. Add one line of Python code within the for loop to start a conveyor, all the conveyor belts, and move the spawn boxes along the conveyor line. So we're burning the boxes using the tire fire. Got it. Okay, so I use left click. No, I was gonna say I just want to move. Okay, so let's look at our code here. That stuff all is the same. We're finding all of our conveyors. We're looping through all of our conveyor belts, because we just have this thing that loads them into an array, or a list they're called in Python. It's all the same nonsense, really, at the end of the day. Don't worry about it. Here we're just printing the entity name, because why not? And then we need to set the speed. Are we going to have any kind of completion here? We are. Hot shit, man. Set target speed. We want to set target speed to 10. You want me to set it to 5? Okay. I can set it to 5, I guess. Let's run it. Initiating Python. Can I see the screen? Can I put this away? I can. There it goes. We have some glass things on here, it looks like, that contain the boxes as they go on their turn, just in case you turn this thing up. But there you go. Let's see, we're looking at some stave stuff while we have our boxes in transit. Guess I can use WAS to move around here. Let's go with the tire fire. Called interpreted language because the meaning of programs are very vague and up to the reader to actually figure out. It's called an offside rule, which is a reference to sports. Most programmers don't know anything about sports or about coding, so it all works out. I really should have set the speed a little higher, right? Well, it's happening. We're going to recycle these. Well, that was very explosive. Where are these briefcases, by the way? How am I supposed to find a briefcase? Huh? I don't see any briefcases around here in the darkness. Is it in... Is that it? a very interesting looking game, actually, with all this. Maybe this one doesn't have a briefcase in it. It's all very noisy in here, too. Well, have you ever been to a recycling plant, Ikami-sama? You can't say that they don't, don't just put all the recyclables into the garbage. There's a briefcase. No, the briefcase, no, I want it. I don't want to finish. It's right there. What? I want to see the cool information. We'll be back. We'll be back. Maybe I'll look before I do that next time, huh? Or maybe I'll just retry this and we can click on the briefcase. Alright, out my face. Okay. What am I supposed to do with the briefcase? That's clearly it. I'm clicking on, nothing happens. Very sad. Oh well. Can I just skip to the next scenario? I guess I can't. Well, let's go ahead and program some more. Oh, it has my old program in there. Can I set this to like 500? Not sure why it has to be afloat, but it does. Run. Interesting. What's all this? Tween target float, target speed 5. That doesn't look like 500 to me. I'm disappointed and my day is ruined. That is not 500. You need to click the latches or the lock on the case? Let's see. There are some latches there. Oh! We found the magic pixel. A laser rangefinder is a device that allows us to measure the distance to an object with incredible precision. It works by emitting a beam of light, which travels to the target object and is reflected back to the rangefinder. By measuring the time it takes for the light to make this round trip, the rangefinder can calculate the distance to the object using the known speed of light. This concept is called the time of flight calculation. Neat. I hope you've enjoyed this edition of Thing Facts. They didn't even set the tires on fire this time. Disappointed. Yeah, I don't know what I clicked either. I just clicked on the side of it enough and then it's like, oh, he's clearly found it. Well, we can speed this simulation up. Weasel tilts his head. He tilts it further. Further. Oh, I need it. Of course. Whatever, man. Whatever, man. Use the clear button to clear all your code and reset the tutorials. Okay. What if or else? If conditionals. Import random. If it's lower than 5, heads. If it's greater than 5, tails. These simulate the flipping of a coin. Let's check out how. First, we generate a random float between 0 and 1. I'm not reading the text, I'm just telling you what it means, because I know what it means. We put that into this, and we say, if it's less than 0.05, then it's heads. Otherwise, we're going to print tails. So here we got 0.01, that is less than 0.5, it's going to go to heads. But if we got 0.7, that's greater than 0.5, so it's going to be tails. It's just that simple. You're now a programmer. And you can see how that works. Let's go do some conditionals. Unlock the if statement. It's fucking dumb. What? Excuse me? No, I want perks. I want if statements, please. The list data structure. Don't we already have lists? I'm fairly sure we already have lists. But maybe I'm stupid. Oh. So we have an assistant. I wonder if that's AI activated. It could be. I use AI in my current coding because, I mean, it's actually pretty good at saving you time. It's GitHub Copilot is what I use. So what do you want me to use? You want me to use the laser rangefinder? We learned about these. We can learn more about now. Oh my god. So we have the RFID box. Returns the RFID tag of an entity currently hit by its rangefinder. Returns an empty string if nothing is hit. Okay. It's a box. It's a tag. Okay. Move 5 barrels to the container on the right, and move boxes to the container on the left. Alright. Makes sense to me. So let's look at the code. What we got here. A lot more code. So let's see. If the tag box is sent to the... if the tag is box, rather, set the conveyor speed to be backwards. If it's barrel, set it to forwards. Alright. Seems simple enough. I'm just looking at the 5. Why is it 5? I guess we're just showing what it is. Okay. Well, we don't need any of this. This is dumb. We're going to use an if statement. We're going to go if. And this is weird with Python. You can actually use parentheses here if you want to. But Python doesn't use parentheses by default. If box, if tag, you dumbass, equals box. We can use... Can I use single quotes here? They should work. We'll see, I guess. I want you to set the conveyor speed. I do have the conveyor. Good. Set speed. And I want you to be -5 because I don't want this to take 1,000 hours, alright? But you want it to be -2. No, fuck you. Else, now I want you to go to the other side. Break out through to the other side, yeah. Burp, 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 derp, derp, derp. Alright, get out of here so I can see. Okay, that's a box. I like how the rangefinder can read RFID tags. That's also nice. That's a barrel, and it goes the other way. See, just like that. So, do we have some more facts to find? Facts. Facts. Oh, there's the facts. Mom, I can't click the facts. Facts? 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 Facts! Why can't I get the facts? Mom. The facts are right there. I'm rapidly and furiously clicking on every orifice of this box, and it's not working. Why are you being so difficult? It's the grimace of boxes. I'm even clicking around the box just in case that works. Okay, so it's telling me changes in the speed. Got it. That's weird. Ah, I clicked the right area, everybody. It went away immediately, but I clicked the right area. I really wish we could see what our facts were, but apparently it's not that important. Barrel secured. We're the coolest. 20 thing bucks. Oh, this is the last level of the demo version already. My goodness. It's significantly harder than the tutorials. Good luck. Let's see how hard this level is. Precision parking. Okay. Move the drone precisely 3 meters in front of the rangefinder. Stop there for 5 seconds. And then what? Gonna say, let's see, park there for 5 seconds. Parking duration. Okay, so I just have to park it there for 5 seconds? I don't understand what the challenge is. All right, sim time. 5 seconds. Okay, so we're keeping track of time. We can't just sleep on this? It's weird. I mean, surely we could just do it that way. While run main. I mean, what else are we going to do? Let's see. We don't know what we can do with this particular thing ball. What do we have for this? So this is the drone. All right, cool. Copy that. And then we just need to set a thruster force, huh? Okay. And then we're going to have to use the rangefinder to stop it, I guess. It's not really what I wanted, but thank you for saving that line of code, jackass. Maybe I wanted to get the code to actually find the damn thing. Service drone, find drone. Shift-click the copy from tooltip. Okay, well, service drone, find drone. We'll just remember that in case this is stupid, which it almost certainly will be. My God, it actually worked. My goodness. We need some music during this, by the way. Come on, Pretzel. There you go. You always gotta have some coding tunes on here. Do it within 15 seconds. Oh well. I'm not here for your challenges. I'm here to have fun playing a video game. We'll probably need this thing also. Alright, shift-click that. We're also gonna put this out in a different place on this because putting it here is stupid. We don't need to find it all the time. We'll just put it here outside the while loop. Alright, so now we're going to give it some thrust. Let's go drone. Force left, force right. Do we have a forward? Impulse left? One moment. Lethal tilts his head. I see. Okay, cool. I like how we can experiment with this. You stop that. Ah, I see. So, okay. Reset the simulation. Now if I go ahead and hit both of these at once, it should actually go forward, right? I guess I don't need my phone chat here. That's fine. Okay, so if I fire both of those at once, it should be good. I'm not sure what kind of force we're going to need. But I guess we just need to get there. Alright. Well, let's go ahead and say drone, apply, impulse left, 100? Sure. Let's make a variable for this. Not 1,000, please. There we go. Thank you for completing my variables. I appreciate you. In fact, probably should just make a function for this shit. Oh well, it doesn't matter. Doesn't matter. Alright. We could just say, hey, if RF find speed, get distance less or greater than 5, right? Because it was 5 meters away. Or 3 meters away. Now I want you to keep booping it up there. I'm used to using 2 spaces nowadays. Tank style movement. Does the thrust last? We'll see in just a moment. Important modules are locked. I need to unlock some modules, okay? I can't get import? Lethal looks at this. I can't make that. Network what? What do you mean I can't import time, you piece of trash? Alright, well, I'll figure it out in another way. Not that I really need that stuff anyway. Let's not import time. Even though it's a standard Python module and it should be available, goddammit. Shorten this up so it doesn't do stupid shit. Alright, is that good enough for you? Good. There she goes. Where she stops? Well, it's a little close. Precisely. Okay, so I need to back it up a bit. Because that 200 or 100 is a bit much. Let's stop. We'll go ahead and go with 10. And let's see what that does. Let's reset and just see if we can park it in front of there. Spin lock and wait for the thing. Whoops. That's not it. I hear him coming. Oh, he's a-coming. Don't get too close now. Okay, so it's still not quite there. Let me see if I can back her up. Because it has to turn if it actually wants to do the other thing. Might vary based on distance. It kind of did feel like it was slowing down as it got there. So let's go ahead and do that. Do we have case statements? Can I make a case statement, Mom? I mean, I could always... If I want to do this calculus style, we could always just make the thrust how far we are away. That'd be fun. Let's do it. Stop it. Alright, I want you to make the thrust power equal to the distance we are away. Let's store this. Away to the abyss with thee. And maybe, and actually what we should do so if way, I mean, we don't even need an if statement here, technically, unless we're exactly at 3. Can I break? That's the one thing. If away equal to 3, can I just break? I probably have to unlock the other things, but can you break? Can you break out of the loop? Or do I need to unlock that? We'll just leave that there. So break. Otherwise, I want you to go ahead and apply the difference. And do I want to add that or subtract it? I think away minus target. So if it was something like away was 2 and we minus 3, then we get some negatives in there and it should apply negative force to get to that. Alright, let's see how stupid that is. Diff. And maybe I'll use thrust power as well. Somehow. We'll see. This is not going to be terribly fast. Let's try... If diff is greater than 3... diff times thrust power. There we go. Now we'll just apply power, and it should be good. Now, if I could just type. Please stop completion. This is one reason I hate IDEs. Is because sometimes the completion gets in my way. We have some shitty variable names. It doesn't matter. This is a game. Now, you can learn that later. I broke the program. Power is not defined, is it? Ah. So this is a Pythonism here. So let's make power equal to diff. You're like, why doesn't power exist? It's right there. It's because it exists only within this block. So once you go outside this block, this thing is out of scope and no longer exists. Alright. Let's see what you're doing out here. Oh, it's cooking something up. Okay, so it can't have a negative impulse. Because it's stuck at the same amount. That was me being stupid. I didn't realize it couldn't have that. Sir, could you stop being on fire? Thank you. So, if it does that, we're gonna have to fucking turn around. How much force does the... Whoops. Turn these back down. I heard that sound. Well, did we win? Okay, so we have impulse and then we have regular force. Interesting. Reset the simulation. This is a fun challenge. We're at time, but I want to see if I can figure this one out. Figure out how to make this damn ball do what I want in this shitty code I've written. Alright, let's not do that anymore. We'll just make power the diff. Alright, now let's see what you do with this, that. Is that going to be too much? It's going to take a while to get there, but it should do it. Look at it bobble. And because of how we have it, it's going to just get gradually slower and slower and never approach that point. You can see that the impulse is just gradually approaching zero here. Through the power of calculus, we are going to get there. We didn't even need any kind of quadratic equation for this sucker. So just lay back and relax and let this thing eventually get within millimeters of it. I mean, we are within millimeters. I'm interested to see if it will actually get there now. Xeno's thing ball. The slowest impulses you've ever seen this summer. Alright, let's reset this sucker. It's gonna take literally our entire lives to get there. How can we make this just a bit stronger? We need to have, like, a minimum power, I think. Because we were at, like, 0.23 there. Let's make minimum power. Let's see. Min power equals 0.05. We can go ahead and do one of these. I wonder if I can use one of these statements. We'll see real quick. You're not gonna let me use that, right? Ah, I thought you would, you piece of shit. What do you mean? Oh, did I do it wrong? Pretty sure that's valid in Python. Or am I thinking of other languages? They have tertiary operators, don't they? Python, ternary, excuse me. Oh, you gotta use actual if statements. Damn it, Python, you fooled me again. Alright, let me see how that syntax was again. Okay. This is why I didn't use these too much in Python, I guess. That's a regular statement in Ruby or also in JavaScript for that matter. So we want to go if. I think that's how I was saying it. If diff is greater than min power, else min power. What an ugly but sensical way to read that, I guess? Okay, cool, that does work. Alright, so now it should never fall below 0.5. So it should eventually get there a bit faster. Come on, baby. They didn't say we need to be there, you know, this century. But we will get there this century. Once seen a statement that took up 4 lines, had a ternary operator nested inside another ternary operator, and had no body. I'm interested to see some of the other solutions people have made for this. Like, do they have it doing some sweet spins onto it? That seems like a big pain in the ass. Because just turning this thing around is pretty much impossible to do in place. Okay, we're quickly approaching it. And then it just needs to break if we're actually there. Here it comes. Oh my goodness. So it looks like the impulse actually takes the exact... We did it! We're the best. It's still doing things, don't worry. We were parked there, close enough for it to be happy. Our memory beats 3%, hell yeah! You gotta use more memory. Our time beats 1%. The best. Alright, well that has been a fun little thing. You could solve this in any other variety of ways, but that was my stupid way of doing so. I hope you enjoyed. I did kind of enjoy this, even though I was hesitant to try it at all. Thank you, Ryelder, for pushing me to do so.